Hello everybody, hope you're doing well. My name is Mahmoud Kiasari and welcome to the new chapter of Advanced Algebra. So at this chapter we are trying to talk about the radicals and some of the equations that we can have based on the radicals itself. We are going to talk about different kind of solutions, different kind of way that you can find a solution, and some of the flaws and some of the pitfalls that you can some kind of trap inside them if you don't know what's going on. So by specifically I mean that sometimes you do have radical equations, they're going to give you some answers, but those answers are going to be just lies. That's why this is the topic of this board, which is that an equation that lies to you. For instance, we do have the radical of x plus 9 subtracted by the square root of x minus 3 is equals to 3, and we are trying to find the solutions for this one. So at the end of the day, we find out that this guy is going to give you two answers, but one of them is lied, and we are going to see that why. The very first thing that we have to know is about how we can go from chaos to clarity. And the goal is of the simplification. It means that for the chaos, I do have something like this, that the square root of 800 x to the power 11, and I would like to find a way in order to convert it to something like this, and better, 20x to the power 5 root of 2x. And we would like to see that how we can do that. The very first thing that we have to know is just some kind of names. So the first one is about, imagine that I do have this guy, roots to some kind of 1, which is just a coefficient, multiplied by square root of 16x to the power of 8. The number beside this radical is considered as radicand, and I do have the index that is going to be over here, and I will show you that how we can handle that, and this is just the coefficient itself. So first of all, or before do anything that is related to radicals, we have to know a couple of rules, a couple of laws or a couple of toolkits that is going to help us in order to find the actual solution. So the very first thing, or the very first method, is about splitting exponents, which is somehow considered as a division method. What does that mean? It means that when we do have a condition that we are trying to find the root of a to the power of n, why we know the index is n. By the way, when we are talking about the root of this specific number, n is going to be the number beside the radical itself. So most of the time we know something at the square root of 2, but at this point the index would be a little bit different. So this index is going to give me some kind of hint that I'm looking for what exactly. Imagine that I do have this guy and I would like to somehow simplify it. How I can do that? The only thing that I have to do, I have to divide m by n, and it's going to give me two things. The first one is the quotient and the second one is the remainder. By writing down this kind of power inside based on this index and finding the remainder, I can simplify it. How? Let's look at this example. Imagine that I do have this question, root of x to the power 11, root of 3 by the way, that one, and I would like to simplify it. I would like to see that is there any way that I can move part of it that is inside to the outside? The only thing that you have to do is divide 11 by 3 by considering the fact that I need the coefficient and I need its remainder itself. This guy to the power 3 is going to be outside by knowing that x to the power 3 is going to be outside and the remainder is going to trap inside. So my simplification method is this one. It means that I somehow made my chaos to something more clear like this. And some kind of method would be about hunting for perfect powers. What does that mean? It means that we have to scan the radicand for factors that are going to be perfect squares, cubes, etc. What is the perfect squares? For example, x to the power of 2 is a perfect square. 16 is a perfect square because we can write it down as 4 to the power of 2. 64 is a perfect square, and so on and so forth. So imagine that I do have a system like this. First of all, I have to work based on factoring. I do have a number. I do have x to the power of 2. I do have y to the power of 3. I'm looking for something to the power of 2. Imagine that I can write down the 72 as two numbers, 2 times 36. So 2 times 36 means that 2 is not a perfect square and 36 still is a perfect square. So what do I have? I do have 36 or 6 to the power 2 itself. After that part, I do have the x to the power of 2. It was actually x to the power 4. It was actually x to the power 2 to the power of 2. So that's a good one. I like it. And y2 is I like it as well. So why I can write it down as y2 times y or y to the power of 1? Because as we all know, y to the power of 1 multiplied by y to the power of 2 is y to the power of 2 plus 1 is going to be y to the power of 3, which is something that I like itself. At the end of the day, I don't like this one. At the end of the day, I do have 36, I do have x to the power 4, I do have y2. I can some kind of move them outside of my radicand by knowing the fact that I have to consider the radical itself. By the way, how I can reach from this one, we know a fact about the radicals. The root of a multiplied by b can be written as root of a multiplied by root of b. So we know about that. So it means that I can separate these two, keep this one as the way it is, but since I do have the root 2, I can some kind of do it one by one. Root of 36, 6. Root of x to the power 4, x to the power 2, and root of y2 is y itself. As simple as that. So either I can some kind of use the division method that I have to find the quotient and I can find the remainder, or I can find the perfect squares, and based on that I can simplify the whole thing itself. So after that, we do have the art of rationalization. So if you guys remember, when we were talking about the previous chapter that was about the polynomials, one polynomial on the top and one polynomial on the bottom, the very first thing that I told you, after obviously find your restriction based on the fact that your denominator is going to be 0, because at the end of the day it caused some undefined condition, try to get rid of fractions. And by getting rid of fraction, it means that you have to multiply some kind of your numerator and denominator by your denominator itself in order to get rid of that. So at this point, we do have somehow the same idea, but with a little bit of difference itself. So the very first way is for the rationalization, in order to cleaning up the fraction itself, is to obviously multiply both numbers or some kind of numerator and denominator itself times this one, because we know root 5 divided by root 5 is 1, so we are not actually doing anything. So by doing that, I do have 7 of root 5, and I do have root 5 to the power of 2. We know that this guy is going to be 5 itself, so I do have this one. It means that somehow I got rid of the radical in the denominator itself. I know we still have the fraction, but it's way better than the previous one, because I can find 7 divided by 5. It's going to be a decimal number and just multiply it by the number beside of that, which is going to be a coefficient and a radical number. After that, we do have some kind of high root example. So what would happen if we do have this condition? Again, we are going to do that, but by doing some kind of exception over here. I do have root 2 by knowing the fact that its index is 3. What is the number that I can multiply by root 2, or by some kind of the 2 inside the radical, and based on the index of 3, I can get rid of that? It means that if I can find a way to make my number like this, these two are going to cancel at each other. Why? Because I can write down this one as 2 to the power 3 to the power of reciprocal of the index itself. This is the law. This is some kind of rule about the radicals. For instance, when you have this one, 4 with the root 2, actually you have something like this. You have 2 to the power of 1 over 2. These two can cancel each other, and you have your 2 itself. So remember about that. So if I can find a number that can be multiplied by this number and give me this, I win the game. What is the extra thing? I need only 4. So it means that if I multiply both sides, the numerator and denominator, by root 4 with the index of 3, I win the game. So I do have 3 times this guy. I do have this one is going to be root some kind of 8, which is the index of 3. So it's going to be 2, it's going to be 3. 3 divided by 2 is 1.5, and I do have everything that I need. Another trick would be about the conjugate trick for binomial ones. It means that if I do have a condition like this, because obviously not all the time my denominator is going to be just radical. If that was just radical, I can do the last part, or I can do the previous section. But if my number was that is a combination of a specific number and radical, it's going to be another scenario that I have to use this trick. What this trick says, if you guys remember about the difference of perfect squares, means that a plus b times a minus b is going to be a to the power 2 subtracted by b to the power 2, just like the way that I have over here. If I can find a way in order to multiply by this number, or some kind of, I consider this one as a plus b, and I consider another a minus b, I can find something like this, and I can get rid of the radical itself. It means that what is the number that I need, or what is some kind of terms that I need to do that? Multiply by 2 minus root 3 divided by 2 minus root 3. So I do have something like this that I can. So it means that right now I can multiply the numerator and denominator by these two numbers. So what would happen on that time? And this time I do have something like this. My a is going to be 2, and is going to be root 3. And based on this one, based on the difference of perfect squares, it would be 2 to the power 2 subtracted by root 3 to the power 2. So I do have 4 subtracted by 3 is going to be 1. It means that my denominator is just gone. It's just 1, right? So on the top side, I do have 2 minus root 3. So at the end of the day, it's going to be like this. This is the clean result. We didn't get that by accident, but it was by design itself. So be careful about that. So what would happen if we do have the cubic on the some kind of denominator and somehow we have to get rid of that? So when you do have cube 1, you have to actually use a couple of different things, and some kind of these things needs you guys to know a fact that 3 plus b to the power 3 is a plus b times a squared subtracted by ab plus b2. This is the rule. This is some kind of a law that you have to remember, memorize it. If you have any skeptical, if you are skeptical about the whole thing, how this guy is going to be like this, the only thing that you have to do, just do this multiplication. This term with all of these terms, at the end of the day, you have something like this one. So by knowing this fact, the sum of cube is like this, we are going to solve some questions. For instance, I do have a condition that I do have 1 divided by root 2, or root with the index of 3 plus 1, and somehow I would like to get rid of this one. If you look at this section, you can see it's a root 2 with the root of radical of 2 with the index of 3 plus 1 can be considered as a plus b. It means that if I can find a way to add this one or multiply the whole case by this guy, I can write it down like this, and if I do have a to the power 3, I can get rid of this radical itself. So first of all, let's talk about my a and b. At this point, I can consider this number as my a and this number as my b itself. So it means that the second number that I have to multiply the top and bottom, the numerator and denominator, would be a to the power 2 subtracted by ab plus b2. What is my a to the power 2? It would be root 3 times itself, which is going to be root 4, 3. And my ab is going to be this guy, because we are just multiplied by 1. And after that, I do have the 1 itself. It means that if I multiply top and bottom, not only these two guys I can cancel out each other, but I also can use this guy to be multiplied by this one, and at the end of the day I'm going to reach to something like this. So if we do that, we know we do have a to the power 3 plus b to the power 3, 3 plus this number to the power 3, whatever we have on the top. So it would be 3 on the bottom and whatever number that we have on the top itself. As simple as that. The only thing that you have to know right now in order to get rid of index of 3, the radical that it has the index of 3, and the index of 2 most of the time would be about difference of perfect squares and sum of cubes. This a to the 3 plus b to the power 3 follows the formula a plus b times a squared subtracted by ab plus b squared, and a plus b times a minus b is a to the power 2 subtracted by b to the power 2, difference of perfect squares. So after that, we have to look for a way in order to solve the basic radical equations. It means that at some point, at least one of the terms would be beside the radical, or is going to be behind the radical. We have to find a way in order to solve those equations. So probably when we do have a radical, most of the time we are talking about the power of 2 to get rid of that. But it has some steps, and these are the steps that I'm going to talk about. So the 4 steps of protocol. First of all, isolate a single radical term on one side of the equation. For instance, if you have something like this, make sure you do have one side that is just related to radical. Check. After that, square both sides to eliminate the radical. It means that I have to make this guy to the power 2 in order to get rid of this radical itself while keeping the balance. Check. After that, we have to solve the resulting polynomial equation, and also the final and very important part is that I have to find the solution. But as I just told you, by using the power of 2, we are going to make another answer that we don't like. Why we don't like? Because if you look at some kind of radical, you see that we do have some kind of limitation related to the domain. It means that I cannot use any number beside the radical itself. 2x minus 1 cannot be negative, because right now I don't know anything about the root of negative numbers, so it's not going to be considered. So 2x minus 1 should be bigger than 0. It it means that my x should be bigger than half. Whatever number that I got should be bigger than half. If that is not, it means that I do have an issue. Probably I'm going to face that problem. That's why I have to check almost everything. So let's look at this example. As I just told you, isolate my some kind of radical in one side and have other things on another side. Find the power of 2. So it means that root or radical of 2x minus 1 to the power of 2 is what is going to be 2x minus 1 itself. Then I do have x minus 3 to the power of 2, which we know how we can find it. It would be x to the power of 2 subtracted by 2ab or 6x and plus 9 itself. So I do have something like this. 2x minus 1 is equals x2 subtracted by 6x plus 9. So the only thing that I have to do is to arrange everything to make sure that I do have one side as 0 and I do have this one. How we can solve this problem? Again, it's simple. We know a fact that based on the quadratic equation, x1 is equals to negative b plus root of delta divided by 2a, and x2 is the exact same thing with negative psi this between the b and the root delta itself. So what is delta? 64 or b2 subtracted by 4ac. 4 times 10 times what? Time the 1 itself. It would be 24, and since the delta is bigger than 0, probably for sure you do have two answers, and probably one of the answers are not going to be the thing that we like. So the deception is over here, solving the line equation. As I just told you, while you're doing that, you in fact that one of the answers is not going to be the answer that you like. For instance, at this point, it is very important just before even doing this kind of steps to have your restrictions. The first one is that x should be bigger than negative 9, and for this one, x should be bigger than 3. If you find the common spot of these two, means that your x should be bigger than 3 if you would like to make sure that you do have a final answer. So let's look at the step how we can do that. At this point, rather than just having one radical, we do have two radicals actually. So by keeping one radical in one side and keeping a radical and another term in another side, somehow we can solve the solution. So at this time, when you do have two radicals, it would be better to not keep both of them in the same side. Still, you can do that, but it would be a little bit confusing. Why? Because at the end of the day, you would have two terms just behind or beneath your radical, which is not going to be solvable, and it's going to cause some problems for yourself. So keep one radical in one side and move one radical into another side. So let's see what would happen over here. At this point, I just keep my root of x plus 9 as the one side, 3 and root of x minus 3 and another side. And I will use the power of 2 method. So if I have the 2 power 2, it means that power 2 of this one and power 2 of the whole thing itself. So right now the situation would be a little bit confusing, but it's not that hard. My a is this and my b is this. It means that it's still a to the power 2 plus 2ab. I do have this fact. So this guy on the left side is going to just get rid of the radical. On another side, I do have a to the power 2, which is 9. I do have 2ab, 2 times this guy, which is going to be 6, times root of x minus 3, and I do have b power 2. b to the power 2 is just x minus 3 itself. Again, rearrange everything. What do I have? I do have this guy at the end. So when I do have this one, I'm going to reach to the next part, which is something that I like. Again, power of 2 of both sides is going to be 1 over 4 is x minus 3, and this is going to be my final answer. So here's the thing. Is this going to be the right answer? I have to check that. How I can check it? First of all, I have to check and make sure that this guy, or x is equals to 13 divided by 4, is within the range. Since this number, if you find it, is going to be bigger than 3, so probably is right. Another, or the second important step, is the substitution method. It means that I have to put this number instead of x to make sure the left side of equation is going to be as the right side of equation. So if I do that, do I get this some kind of response? So let's do it. Put this number over here. After that, have some kind of a step, do calculation, you know better me, and I see that 3 is equals to 3. So this is the part actually is going we have to say that the lie comes from. What does that mean? When you square both sides of an equation, for instance, a is equals to b, you will get something like this, which is valid, but it's okay. But we do have the new equation. It's also going to have the solution like this one. What does that mean? It means that you have a equals to b, right? If you find this a to the power 2 is equals to b to the power 2, it not only is going to have the first answer, but it's going to lead you to another answer that we don't like. a is equals to negative b. So we're only going to have one answer. The second answer is not acceptable. So at this point, the quick example, some kind of quick check is going to help you in order to make sure by checking the range, this is the first one, the restriction, and also double check your answer inside by substitution method. So at this point, a quick example of a failed check would be root of x plus 3 is equals to x minus 3. If you have one of the solution, it would be what? One of the solution could lead you to a fact that at the end of the day, you would reach to something like this, which is not going to be right. So be very, very careful at that one. So again, we do have the two radical ones, and we would like to again solve that solution. What would happen? We would keep one radical at one side, and we just keep everything on another side. So isolate the one radical. After that, we have to some kind of use this squaring. We are going to square this side and this side to the power 2. It's going to be x to the plus 5, a to the a and b are like this, a to the power 2 plus subtracted by 2ab plus b to the power 2 is something that I liked itself. So what would happen at this point? I do have x plus 5, I do have a to the power 2 subtracted by 2ab and b to the power 2. If you just some kind of solve this equation, you would reach to something like this at the end of the day, and you can have your answer. Still, make sure that the answer that you would find is going to be within the range and is going to be acceptable inside of this one. So this some kind of second answer that most of the time comes when at the end of the day, just one final step before the final, you just have made equation. So quadratic equation obviously is going to give you two answers, and one of them is going to probably be wrong itself. At this kind of situation, it's not that bad, but this kind of fraction or some kind of quadratic equation is going to be problematic. So another thing that would happen that sometimes, and most of the time, would be in puzzles. You just saw, for example, we do have root of x plus root of x. It's going to be some kind of infinite. So those kind of things that have another solution, we are not going to talk about that right now. But this kind of way that we only have nested radicals, it means that one radical is going to be beneath another radical. So what we should do on that? At this time, we are going to align, or we are going to declare as one variable into another thing in order to make a condition a little bit simpler. After that, use that variable and convert it back to the normal that it had. How we can do that? Let's look at this question. Imagine that I do have an example like this. It's going to be root of x plus root, again, this is beneath this radical, is equals to 3. And we are going to some kind of use the substitution method in order to solve that. What would happen if I don't like this root x? Somehow I have to get rid of it, right? What would happen if I imagine that root x is t? Obviously, x means that I have to make both sides to the power of 2, so x is t2. Right now, let's consider that. It means that this guy just converted to what? Just converted to this one. Let's solve this guy. So what would happen at this one? I do have t2 plus t, because I make both sides to the power 2 is equals to 9, and I can solve this problem. So based on that, I do have the delta bigger than 0, so I can have two answers, the first answer and second answer. Remember, these answers are going to be your t to the power of 2, and still you have to make them equal to what? Your actual t, or some kind of your t2 is going to be your x itself, which is going to lead me to the fact that is going to be the right answer. I'm sorry, I made some kind of problem at this point. These answers are going to be your t, not t2, because we are solving this one for t. So if you would like to have your x, you have to make it to the power 2, and if the number it was in the range that probably is, because t to the power 2 all the time is positive, so you have two answers for this one itself that is going to work for this guy. But still, make sure you're putting that, because probably one of the answers is not right, and make sure that you just kind of test it to have the final right answer itself. So what would happen if we do have the nested radicals?